What's going on, guys? I go by the name of Gio. Welcome to my channel. In this video, I'm going to be starting my new Kotlin tutorial series. We're pretty much going to be starting from the humble beginnings of not knowing Kotlin to better heights of getting a better understanding of how Kotlin functions and why a lot of people are starting to use it. So hope you guys enjoy. Alright, so first things first, we're going to need is an IDE. I'm going to go with the IntelliJ IDE because of the fact that it is created by the creators of Kotlin, which is JetBrains. So I believe they will provide the best support for their product. There are two versions of this IDE. There's the Ultimate Edition and there's the Community Edition. The good thing about the Community Edition is that it's free, so I'm going to go with that. And if you look below, you guys can see the things that each of these products support, and both of them support Kotlin. So the Community Edition should be just enough for what we're going to use. Alright, so the second thing you guys will need is the Java Development Kit, or the JDK for short. Currently it's on version 15, and it includes things such as the interpreter, the compiler, and the JVM. The cool thing about Kotlin is that just like Java, it runs on the JVM, so you don't really have to give up anything to run Kotlin. If you guys go down, you'll see different versions for different OS. Well, I mean, it's the same thing, but if you have a different OS, there's a different installer. In my case, I have the Mac OS, so I either use this Mac OS installer to get it, or if you have Windows, you just use this Windows installer and continue on with Linux. So once that's finished downloading or installing, you just go through the instructions. Usually I leave the location of the JDK as default, wherever the installer chooses. So that's just pressing the next button over and over again until it's finished. And then once you have the JDK and have your IDE installed, we are good to go. And also I'll leave a link in the description to both the IDE and the JDK. Alright, so now that we have IntelliJ and the JDK installed, I'm going to need you guys to open up IntelliJ. I'm going to need you guys to also click on New Project. Check this checkbox for Kotlin/JVM. For the project SDK, choose the JDK that you guys just installed. In my case, I have version 14, but you could have an older version or you could have a newer version. In my case, I have 14. For the library to use the Kotlin Java runtime and press next. Then we're going to need a name for our project. In my case, I'm going to choose Kotlin Tutorial 2021. And press finish. And then boom. You guys should see on the left your file structure. First, we have the .idea folder, which is IntelliJ specific. This holds information regarding your project, such as navigation history, the current files open, and debugging configurations. Then we have the source folder, which will be used for writing our Kotlin files and code and logic. They'll be placed in here. Then we have the .iml folder. This is this is also IntelliJ specific. It holds metadata for the project. Then we have external libraries, which holds the JDK jar files and the Kotlin Java runtime jar files. Alright, now we're ready to start writing some Kotlin code. So, like I said, source is going to be used to hold our Kotlin files and logic. So let's right click source, hover over new, click Kotlin file/class. So what I want to do is create a Kotlin file to hold our entry point into our application. So what I'm going to call this file is application start. Press enter. Cool. So the difference between Java and Kotlin is the fact that we don't even have to make a class to get started. Really, all we need is a function. So in this case, to make a function in Kotlin, we use the word fun. Simple. And you guys can see that, try to recommend some other stuff, but we just need fun. Simple, very simple. And then we choose a name for the function. There's a keyword in Kotlin that lets Kotlin know that this is going to be the entryway into our application. So we call this thing main. This is the main entryway. This is the main gate. This is the main door. This is how we'll get into this application. then, for functions, we'll need a parentheses. So we just open and close parentheses. And then we have curly braces. Within this curly braces, this is going to run the logic that we put inside this curly braces. This is the body of our function. So I think it's an international standard to print out something when you're learning a language for the first time, or when you're building an application for the first time, just to see that it's working and that it's running and that I'm not lying to you guys. So the first thing I'm going to do is to print out hello world. In my case, I want a new line after, so I'm going to put print ln. So this let Kotlin know I want to print something, but I want to add a new line after I print that thing. So then I put print ln, open close parentheses, and to print out text, in Kotlin I have to use double quotes, and really that's in most languages, but in Kotlin it's double quotes, and then I place whatever text that I want to print out within those double quotes. So I'm gonna just put hello world with exclamation point because I'm serious. And then you click this play button right next to this function. Run application start, which is the name of our file. And then if my computer isn't so slow, you should see it pop up soon. Boom. Hello world. So let me just go over this again. We made a file called application start.kt. We made a function, and to make a function in Kotlin, you use the keyword fun. Then you specify it with a name. To let Kotlin know that this is going to be the entryway into our application, we have to use the keyword main for the function. Then we open and close parentheses for the function. And then we open up a body of the function so that it can see what exactly we're trying to run on the entryway into our application. So within those curly braces, we want to let Kotlin know, to start off, I want to print out hello world. And I want to print out with a new line, hello world. So yeah, that is how you get an entryway into Kotlin, and that is how you print something in Kotlin with a new line. Alright, so we dabbled a little bit with println to print out some data and add a new line. But I just want to explain to you guys there are two different type of functions that we can use to print out data onto the screen. So first we have print, and the second one we have is println. So let me show you guys exactly what this looks like. So we have print. This is just to output data onto the screen. Alright. It is not restricted to just strings or just text. You can print out all these data types that you guys see, Boolean, bytes, chars, doubles, all of this. And I'm going to go over that a little bit more later on. But I just want to let you guys know you're not restricted to just text. You can print out different types of numbers as well. So in this case, we're just going to print out 7. All right. And then let's print out one more thing. Let's print out 14 so I can show you guys the real difference between print and println. So we just print this out. We will see 7 and 14. Print just prints out data onto the screen. Nothing more, nothing less. Now, if we were to use something like println, this also prints things onto the screen. Same type of data types as well. But the ln portion of it adds or appends a new line onto the printed message or after the printed message. So in this case, we'll have a prompt. Let's put my name is, let's lowercase that y, and this thing does not want, okay, there it is. And then let's put a colon for looks, and then let's put another println to put my name, and then let's run that. All right, so boom, you guys can see it prints out 7 and 14 like before, and it also prints out my name is. But then because of the ln, it appends a new line right after this message. And you guys can see that Giovanni is added onto a new line. You guys can see that my name is still on the same line as the numbers because print does not add a new line after it prints out text. It just prints it out to the screen, no instructions. And then after this println, which is my name is, it just adds a new line, and then Giovanni is placed on a new line. And if we were to put a print right under Giovanni, let's put tech with Geo. you guys will see that this is also on a new line. Even though this is print, it is on a new line because of the fact that Giovanni was appended with a new line after the message was outputted. So Tech with Geo takes that and it's added onto the new line. So it is all about preference. Do you just want to output data onto the screen, or do you want to output data onto the screen with a new line? Do you want to put it row by row? It's all about convention. Alright, so variables are namespaces in memory that holds different types of data. Kotlin uses two keywords to specify how this data will be held or how it can be manipulated in memory. So the first keyword we're going to use is val. Val lets Kotlin know that this data will be read-only. Once we pass information to this variable, the data cannot be changed. So we start off with the keyword, which is val, which lets us know that it's read-only. Then we specify a name for the variable. So in this case, I want to hold a value that will hold the day of birth, which is the number. So I'm gonna call it day of birth. I use camel case, which is first start off with a lowercase letter for the first word and then uppercase for the next couple words. Then I use a colon and then pass in int. This will let Kotlin know that I want a variable called day of birth, which will hold a int, which is a number, and we'll pass in 11. And then we'll have another variable, which is val, read only, month of birth, and then colon, an int, which will let Kotlin know that this is going to be an int, an integer, a number, and then pass in 7. Now, to show that I'm not lying, that this information is actually in day of birth and month of birth, we're going to print this out. Let's use println because I'm going to make it a prompt. So, month of birth, colon. Then we'll use plus to concatenate it. We're going to go into a thing called string templates later on. But for now, I'm going to show you guys that you can literally just add on a variable to a string or a number, whatever message that you're going to put into this print. Just add a plus to concatenate it. So, month of birth. And this weekly line that you're going to get will let us know that, you can use a template, but we're going to go over that later on in the series. And then print another println to print out the day of birth. So we're going to put day of birth, colon, concatenate it with the variable day of birth. And then if you play that, you will see month of birth and you will see day of birth. So it is holding the information that you're assigning it to this variable. And yeah, this equal mean is pretty much assignment operator. You're assigning 11 to day of birth of type int, which is read only because of val, and you're assigning 7 to this variable of type int using read only. This cannot be changed. Your day of birth cannot be changed. Your month of birth cannot be changed. That is a fact. Alright, so the second keyword we'll be using is var. Var lets Kotlin know that the information that we're about to store can be changed later on. The information is mutable. So we can read the information and we can write the information. It's pretty much the same approach as val, which is we just choose a name for the variable, which in my case, I want to choose name. Because sometimes the name that your parents chose is just not right. It's not right for you. So in my case, I want to change my name. And this variable is going to hold a string, which is text. And the name that I want to change to is Bobby. Alright. And then I'm going to use one more var. And we're going to call this last name. And we're going to infer, or we're going to let Kotlin know that this is going to be a string, which is also text. And the last name is going to be Boucher. Some people change their last names, maybe they get married. Some people don't. it's really up to you if you want to let the person change their last name or not. In my case, free reign. Bobby Boucher. I let you guys, figure out where that's from. So now we can print out, our first and last name. Actually, let's use ln. So our first name, or my first name, or actually my new first name is, and then you concatenate that with name. Actually, let's make it more specific. First name, and then first name, and then print ln my new last name colon, then add last name, and then let's print that. Oh, well, I can't spell, I guess. Last, let's run that again. But as you guys can see, it's a val, and then that's printing out the first prompt, and then our var is printing out my new first name is Bobby and my new last name is Boucher. But the cool thing about var is that, maybe I want to change that again. And let's change first name to Pops Boucher. And then let's grab that first name again. And then if we print that and run that, you will see, boom, my first name is Pops, but the initial one was Bobby. So it only changes when it gets to this line. After that, that becomes the new value that we assign to first name. So before, if we use val, which is read only, once we even think about changing it and trying to assign it a new value, Kotlin already sees that, no, that's not what you agreed with initially. You said it's val, it cannot be assigned or reassigned. It'll let you know, do you want to change it to var, which is mutable. It could be changed. So you got to think about these things when you're creating an application. Like, do you want the information to be changed? Or do you want it to just stay the same value once the information is being assigned to it? By convention, it's recommended that you use val, but if you know the information is going to be changed, use var. Alright, so the cool thing about Kotlin is that we can let Kotlin infer the type of the variable. So before we were specifying the type that we want to hold into this variable, but we can literally just remove all of this. We can remove the data type that we specified it to, and we can let Kotlin infer the type. So in this case, if we were to run this, we can see that it works perfectly. Kotlin was able to see that this is a string without us specifying it. Now, the issue is if we try to pass in another type, this will cause a problem. Literal or integer literal does not conform to the expected type, which is string. So because we instantiated this originally with a string, which is Bobby, we can't just make it switch into another data type, because that's not the contract, or that's not what we agreed on. We let Kotlin infer that this is a string, so it has to maintain that data type, which is a string. So let's leave it as a string. But this is a very powerful tool with Kotlin. Sometimes we just, we don't have to. If we know exactly what to expect with the type, we can let Kotlin infer it. And that saves some time. Alright, so let's start talking about data types in Kotlin. So the different data types that we have are numbers, booleans, characters, and strings. The first type we're going to go over are the integer types. So first, let's talk about the byte. This is a data type that is 8 bits and can hold a small number value. So the minimum value is -128 up to 127. I will add a little chart so you guys can see, you know, the different types and the sizes. But a bit is the smallest integer type. And to create one, let's make a file or a variable that is of type val, which means it's not mutable. Let's call it is byte, and we will use a colon to specify the type, which in this case it is a byte. And we are going to live life on the edge and place the smallest value that a byte can hold, which is -128. Now, if you guys try to go less than that, it's gonna give you a little warning where it says that it's a mismatch. This is really an integer because the range is past what a byte can hold. So you just gotta make sure that if you're gonna use a byte, which is very small, you gotta make sure that you're only going to store a very small number, because if you try to put something bigger than what it is, there will be a problem. So the next one we have is a short type. This is a 16-bit data type, and to make one we're going to use val, which means it's not mutable again, and this is bothering me. All right, and then is short, and we're going to specify that as short, and we're going to make that equal to the max value of short, which is 32,600 or 32,767. If you try to put anything bigger than that, it will also throw an error. So just make sure that you know you want to hold something that is 16 bits or something that's up to 32,767 or within the range of -32,768, that range of numbers. The next one we're going to go over is an integer type, or int type to be exact. So it's going to be val is int. This is a 32-bit data type. I mean, it can hold a very decent amount of numbers, and we're gonna make that equal to, let's make it 1 million. So another way, as the numbers get bigger, another way to specify a number or a big number in Kotlin, to replace commas you can use an underscore. This will make it more visually pleasing to see. You know, a big number like this, because before it would just be without these underscores, and it just, how many zeros do we have right now? But we can put these underscores to pretty much mimic a comma, and it just makes it, you know, an easier experience. So yes, this is an int. It is 32 bits, and usually if you don't specify a type, if it's within the range, Kotlin will infer an integer to be an int type. So int is the default type for numbers. Now the next one and the last one of the integer type is the long, and this is the biggest type within the integer type. It is 64 bits. It's double of an int. So if you know you're gonna store something of a huge amount, then you use a long. And to do that, you just use the long data type, and then you can place a big number. In this case, we'll put 20 billion, and it can store more than that. So now to specify that this is a long, you need the L at the end of the number to let Kotlin know that this is a long. Now, if we were to use a number that is still within the range of an int, Kotlin will infer this value as a int. If we didn't specify the L at the end, Kotlin would say, okay, this can be an int, so it might be an int. But if we really wanted a long, to make sure that this is a long, you have to put an L at the end. Obviously, if it's out of the range of an int, Kotlin will infer this as a long. But just to be sure, if you know you want a long for sure, just put an L at the end. So these are the 4 integer types. What makes them different is just the range of numbers that they can hold. So you just got to figure out, you know, how big the number you're going to use, or how big can a number get within your application. All right, so the next data types we're going to go over are the floating point types. These are pretty much decimals. Now we only have 2 of them, so we're going to go over the first one, which is the float type. And we're going to call this is floats. We're going to specify it as a float, and we're going to make it equal to 3.14, very basic pi. But with float, you have to add a suffix of f, just like long. Add a suffix of f to let Kotlin know that you're trying to use a float type. A float type is 32 bits, and we have a second one called double, which is 64 bits. And to call this is double, we can specify it as a double, and we'll make this 3.4. And I don't know, I didn't memorize all the numbers, but we can just spam it. But yeah, this is double the size of a float. Now, with the float and the double, by default, Kotlin will infer that it's a double. It's a little bit different than with the long, where if it's in the size of an int or in the range of an int, it will just infer it as an int. But if it gets big, then it will just infer it as a long. In this case, a double can hold anything that a float can hold. So if we don't specify it as a float, by using f, it's always going to store it as a double. So if you really want a float, if you really just want 32 bits, then you have to specify it as a float, and you have to use f. Or Kotlin would infer it as a double. But yeah. Now, what makes it different is that because of the fact that a float is only 32 bits, if we try to push it, a little bit too far, there will be a cutoff because of the fact that a float can only hold 6 to 7 decimal digits. So we have 3 here, then we have another 3, and then we have this 8. So after that, and we'll print this out so you guys can see, there will be a cutoff. So we can print out is float, and let's just use string templates here to make our life easier. Floats, and then we'll add that right here to print this out. If we have to print this out, there should be a cutoff, and it shouldn't be the same number that I have here. So boom, it cuts off at 8, and it rounded that last 7 to make it 8. So it only held 6 values after the decimal point. So if you want it to be bigger, you just use a double. And honestly, we'll just take this whole number and put it in the double so you guys can see. And even with double, there is still a cutoff point. A double can only hold up to 15 to 16 decimal digits. But let's print this out. Call this a double, and then we'll print out is double. If you run that, boom, it printed out everything because of the fact that double can hold way bigger amounts of numbers. And we can also reach that limit too. So honestly, you just got to be careful to how precise you want it to be. And honestly, you guys can see that the last number here is 8. There was a cutoff point somewhere. Honestly, there's too many numbers for me to tell, but just go by the chart. You can go up to 15 to 16 decimal digits. So you got to specify which one or how much you need to hold, or how precise you want the number to be. Now it's time to go over the Boolean type, and this is probably the easiest one to understand. All a Boolean is a value that returns either true or false. I mean, that sounds pretty, straightforward to me. So let's see this in action. So we'll just create a val. We'll call this is true, and we're gonna make this of type Boolean, and we're gonna make this equal to true. It can't be 1. Yeah, it can't be 1, can't be 3. It has to be true. And let's create another one called false. and perfect, just true or false. And later on, when we start to get more into nulls, it also could be null just in case, you know, you're taking an input or you want to specify as null. But for the most part, Boolean is just true or false. And we'll just print that out because I didn't print out the others. But actually, let me just copy this. Oops. Copy that. True. Just gonna print out true, true. But and then we'll call that is true, is true, or is false. And then run that, and boom, I'm not lying. Obviously we still have the float and the double, but we also have the true and the false. Sounds good. All right, so the next type we're going to talk about is the character type. And this just holds single characters. Nothing more, nothing less. So to do that, we can just create a val, call that is char, and we'll just specify it as a char. And this will hold legit a single character. So in this case, we can call this A. And I mean, honestly, we can just print that out. Call this char, and then use is char. And if we run that, boom, it's just an A. Now, if we try to put anything else inside of it, it's gonna scream at you, because if you're trying to use multiple characters, then it'll be the next type we're gonna talk about, which is a string. But let's talk about some special things we can do with a character. Characters have a special function. Now, I'm not gonna go over all of them, but I'll leave a chart. But we can do special things with a character type. We can create a thing called a new line, which we always use println to create a new line after you print something out. But we can also do this with a character. And to do that, we just use a backslash and an n. This is to let, you know, Kotlin know that we want to create a new line, and we're doing that with a character. Now, if I were to just add something random, let's put the word random literally, and we were to print this out, I should see random on a new line, which I do, and there's some space because I have some space right here. But yeah, and then another one I can use is I can use \t, and this means that I want to use a tab or put a tab. So you should see a little gap. Boom. So these are some special character sequences that are built in that you can use to do certain things. So you're not just restricted to just one character, but you also have sequences of characters that do special things. So the last thing we're going to talk about is the string type. A string is a sequence of characters, and we used it a little bit when we print out, but we place them within double quotes. So to specify a string, we just use, you know, let's create a val and our variable, and we'll call this is string, and we're going to specify that it is a string, and we're going to make this equal to this prompt, hello, I am a string. And a string are immutable. Once you create a string, you cannot change its value or assign a new value to it. Now we can transform it or change it a little bit how it looks, but everything stays the same within the string. So first, let me print out this prompt so you guys can see that this is actually a string, and you know, I can just, you know, print this out as just a straight up string. This is a string. Hello, I am a string, because it is a string. But let me talk about what I was talking about before. So like I said, it's immutable. That means that once I create a string, the value cannot change, or I can't assign it a new value. So if I were to use a built-in method that comes with a string, which is or uppercase or to uppercase, this will take the string and uppercase it. and if I were to print out the same string right after, it should say the same because a string is immutable. So if I run this, I will see, oh dang, I forgot to put ln. I always make that small mistake. So if I were to run this again, and if I were to use this, I should see, hello, I am a string, but then I'm also telling it to uppercase, which I did, but if I go back and print it again, it stayed the same. So a string is immutable, and it stays the same no matter what type of operations that you run on it. So that's another cool thing you should know about strings. All right, in Kotlin, we have operators. The first type of operators we're going to look at is arithmetic operators. These are the operators that you usually see in your math class, such as addition, subtraction, multiplication, division, etc. So let's see them in action. We're going to print them onto the screen so you guys can get an understanding or see the power of these operators. All right, so the first one we're going to do is 2 plus 2. I think you guys know the answer to that. Press play. We should see 4. All right, so that's addition. Let's write a comment there so you guys can see that. It's, addition is, the usual plus sign. The next one we're going to do is subtraction. Can't spell. And then we're going to also print that out. And we're going to do 2 minus 2. Put a space there for looks. And we should expect that to be 0. Okay, cool. That worked. The next one is going to be multiplication. We're pretty much going to do a square, which is multiply. Then we're going to take that println and do 2 times 2. And we expect that to return 4. We use asterisk for multiplication. And then let's do a division. We're going to use a / for this. We're going to use println and then 2 divided by 2. And that should return 1 because anything divided by itself should return 1. Then the last one is modulus. This returns the remainder of the division. So in my case, I want to use a weird example so you guys can get a gist of what I'm talking about. We're going to do 13 modulus 5. We know 5 can go into 13 2 times. So the remainder should be, I'll let you guys guess, 3. So that's pretty powerful if you want to see if something is even or odd. If you guys are, into doing that. So one more thing I'm going to talk about. You're not just restricted to just 2 numbers, of course. You could try to use multiple types of these arithmetic operators together. So you could use 2 plus 2, and then you can plus that or minus that by 7. This will actually work. Obviously, if you have an addition and then you subtract 7 by it, it's going to return a negative number. And this does follow PEMDAS, which is, first it looks at the parentheses, exponents, multiply, division, addition, then subtraction. So it does 2 plus 2 first, and then it's subtracted by 7, which is then returning -3. Now, if we want to subtract it first, we can use parentheses, like I said, to make sure that it focuses on that first and then add the value. So 2 minus 5 or 2 minus 7 is -5, and then you add that by 2. I mean, it's still going to return -3. Think of that. But if we turn that, let's see, let's turn that into 9. It would do 2 minus 9, and then it would add the 2. So it's going to be -7 plus 2, which is -5. Pretty much the same thing. So yeah, or we can just do 9. What's something that comes first? Let's do divided by 2. Let's make it weird because you're not just restricted to, just whole numbers. So yeah, let's make this weird. Let's make this 9.5 divided by 2 plus 2. Just so you guys get the whole feeling of what this does. And it should return a decimal number, which is 6.75. So you guys see how arithmetic works. Let me just put PEMDAS, which is parentheses, exponent, multiplication, division, addition, and then subtraction. This is the order that it looks at. So yeah, there's addition, subtraction, multiply, division, modulus, and PEMDAS. That is your arithmetic operators. Alright, so let's go over another set of operators that we can use in Kotlin. These are going to be the comparison and equality operators. Or we can call them Boolean Expressions because of the fact that when we use them, they either return true or false. So these operators are what we're going to use to compare or check if a value is equal to or not equal to another value. So to start this off, we're going to make a variable that's going to hold the age of Bobby. So let's, give some context of Bobby. Bobby's in college right now. He's a sophomore or a junior. He's about to be a junior, and he is the age of 20. All right. He is almost there, but he's not just there yet. The age of drinking in the United States is 21. So at certain bars, they may ask for his ID and see what age he is. So this is the perfect thing to use for that scenario. Let's check if he is less than 21. So let's print out that logic. So we're going to take the age of Bobby, which is holding the value of his age, and that is 20. And we're going to check if he is less than the age of drinking in the United States, which is 21. Now, we do know that his age is 20, and we are checking if he is less than 21. So what do you guys expect the value to be? Now, if we return this right now, we should know that it's going to return true because his age is 20, and we do know that 20 is less than 21, so it should return true. So let me just put a comment right here that says less than operator, because we use this to check if a value is less than another value. Or actually, let's extract this. We know we're going to use 21, so let's make another variable called age of drinking in US. We're going to make that an int as well. Voice break. An int as well, and we're going to make that equal to 21. So that we don't have to keep writing 21 all the time. We can just paste that in. Age of drinking. And then let's do the greater than operator. This would check if a value is greater than the age of drinking in the US. So let's print that out as well. We'll check if the age of Bobby is greater than the age of drinking in the United States. And we do that using this greater than sign that, most people probably, are shown in, basic math classes at a young age. And then we're going to print out the age of drinking in the US, which is equal to 21. And you guys can change that to 18. I know some places is 18. Some places might even be 16. We're going to run that, and we should also see false. So true or false, that is a Boolean expression. There's only two values that you should expect it to return. So we know that his age is less than 21, and we know that his age is not greater than 21. So then let's check if it's equal to. So let's put equal to, and that's one of the equality operators. All right, so we'll just print ln and age of Bobby. And you guys know that with one equal, it means to assign, a value to age of Bobby. We don't want that. We want to compare. So we use two equals to actually compare a value to another value. So we're going to compare age of Bobby to the, actually we'll just paste that in, age of drinking in the US, which is 21. So is 20 equal to 21? Let's see that. That is false. So this is powerful. If you guys want to create a range of, numbers to check. So like this is pretty much going from, we can count negatives, or we're not. We're going to do 0 to up to the age of drinking in the US, which is 21. If you want to see that range, if it actually is less than, then, it will do that. If you want to see from pretty much 21 to infinity, that's pretty much what greater than is doing. And then if you want just one set value to check to compare, then we do the equal signs. But then we also have a mixture of both, which is the less than or equal to value, which is just println. We're going to take age of Bobby, and we're going to check if it's less than, which we take the less than from above, and then we put it equal to, not two equals, but just one, and then you take the age of drinking in the US to check if it is less than, all right, or if it's equal to the age of drinking in the US. So this would not just have a specific range, but it will also include the equal to check if it is 21 or less than 21. So let's run that. What do we got? What do you guys expect to see? It's true, because it is less than. It is less than the age of drinking in US, which is 21. Although it's not equal to, it is less than. So it's still technically true. So now let's check if it's greater than or equal to the age of drinking in US. So we just take the age of Bobby, check if it's greater than or equal to the age of drinking in the US. We know that the age of Bobby is not greater than the age of drinking in the US, and we know that it's not equal to as well, so we should expect it to return false. All right, that's perfect. Now, one more thing that I want to go over is the not equal to. This will check for sure that a value is not equal to a value, another value. So in this case, we know that the age of Bobby, or let's put that out, not equal to. Let's put println. We know that the age of Bobby is not equal to the age of drinking in the US. So since it's not equal to the age of drinking in the US, we should expect it to return true. It's pretty much the opposite of equal to. If we know that it's gonna compare, if it's equal to age of drinking in the US, we know that this is gonna return false. So if we just put the negation of that, we know it's just gonna return the opposite of that, which is true, because age of Bobby is not equal to the age of drinking in the US. So these are some of the comparative operators and equality operators that you can use to add some logic to your code to check a certain range or a specific value to see if it's actually equal to or within a range of a value. And you're not limited to just using a direct value. You could just put the value into a variable and you can keep adjusting this and it will return, right now if you guys see it says true, false, false, true, false, true. And I'm pretty sure if I run this, it's just gonna change a whole bunch. So yeah, it changed. So if you guys want to add some logic to your application, comparison and equality operators will be necessary. Alright, so the next operator we're going to go over is the assignment operators. You guys are probably thinking, we've been using the assignment operators this whole time, equal. But that's just the simplest form of it. There are other assignment operators that we can use with some additional logic to it. So let's just create a variable called x, and this is going to hold the type int, and it's going to equal to 0. I just want to create a base variable with a value that we're going to just continually add on to. And this is just the simplest assignment operator. Next, we're going to use the plus equal. This is the addition assignment operator, and just as it looks, it's just going to equal plus equal, and we're going to assign it the number 20, and this is equivalent to x equal lowercase x equal x plus 20. So it takes the current value of x and it just adds 20 to it. So plus equals 20. It just adds it real quick. It makes your life simple so you don't have to write all this out. So it's just plus equal, because it takes the current value of x and it just adds on to 20. convenient. And it's pretty much the same thing for every other arithmetic operator that we used. So the next one we have is minus equal, and this is gonna be equal to x minus equal to 10. So we're gonna cut that in half, and that's gonna be equivalent to x equals x minus 10. So it takes the current value, right? And then, which is 20, because we just added 20 to 0. And we're going to subtract that by 10, because the current value of x is 20 at this point. So that should equal to 10. The next assignment operator we're going to use is the divide, or actually, no, let's do multiply. Multiply equal. And this is, following the pattern of above, which is just going to be, multiply, which is just an asterisk. And then we're going to make that equal. And then, let's choose a fun number. Let's do 5, because I want 50. And then we're going to do what that is considered. And that's going to be x equal x multiplied by 5. So the current value of x is 10, and we're going to multiply that by 5, which should make it equal to 50. And then the next one we're going to do is divide equal, which is going to be equal to x divide equal to let's do 2, and that should be equivalent to x equal to x divided by 2. Actually, no, let's make it a whole number, because this is going to make it a decimal, and we're holding an int right now, so it can't really be a decimal. So we're just going to divide that by 10, and then that should bring it back to 5. So that's what it's equivalent to. It's equivalent to x equal x divided by 10. The current value of x is 50. If we divide it by 10, it should be 5. And then the last one we're going to use is modulus, which is x modulus equal, or actually I didn't put the comment, so that is modulus equal, and then that's x, had caps lock on, x modulus equal, and currently it's equal to 5. So if I do modulus 5, modulus returns the remainder. So actually, let me just write this all out. X modulus, x is equal to x modulus, and then 5. And then that should be equivalent to 0, because x is holding 5 here. And then if we do modulus by 5, then it shouldn't have a remainder, so it should equal to 0. And we're going to print that all out so that you guys can see the values on each step. Oops. Probably should have did that from the beginning, but I was so in the zone. I was like, there's no point. But I want you guys to see exactly how it does it. And as you guys can see, it really does shorten. And let me just print out the beginning value so you guys can see it pretty much change values as it goes through each one. So I'm going to run that, and you guys see it starts at 0, then it goes to 20, then it goes to 10 after we subtract it by 10, then we multiplied it by 5, which makes it 50, then we divided it by 10, which makes it 5, and then we use modulus to see what is the remainder. So cool stuff. If you guys don't want to write out this whole thing, this whole assignment operator, we could just use these shortened assignment operators to get the same logic going. So these are the assignment operators that you can use in Kotlin. Alright, so the next operators we're going to go over are the increment and decrement operators. This is pretty much a shorthand way of increasing a variable value by 1 or decreasing a variable value by 1. So the first one we're going to go over is increment. And first, before we do that, let's create a variable, and it's going to be called I, and you guys are going to see I a lot once you start going into loops later on. But we're going to call I, or we're going to make I hold an int value, and the initial value is going to be 0. So to increment, or to use an increment operator for this variable, we literally just take the name of the variable and then we add plus plus. This is shorthand for I is equal to I plus 1, or as we learned before, it is the same as pretty much I plus equal 1, because you know I plus equal 1 is same thing as I equal I plus 1, but you know, I plus plus just literally just adds 1. And if you print that, we should see that I is not equal to 1. We started with 0, we use I plus plus to increment by 1, and you know, and it did that. And it's a very shorthand way of doing it, and as you guys get into loops, this will be very useful. The next one we're going to go over is decrement, which pretty much is the inverse of increment. You know, it decreases the variable value by 1. So just as we use plus to add, we use minus to subtract. So we just put 2 minus signs for decrement. This is equivalent to I equal I minus 1, which is the current value of I minus 1. Or, as we learned before, I minus equal 1, which is, you know, also equivalent to I equal I minus 1. So this will decrement or decrease the value, or subtract 1 by the value that I is holding. And if we print that out, print out I, we should get the original value, which is 0. So this is a very shorthand way of doing it, and even shorter way of doing it, because it's shorter than this by, I think, 1 character, or yeah, 1 character for sure. So if you guys know that you want to decrease it by 1 for sure, or increase it by 1 for sure, this is the perfect operator to use for that, and I am pretty sure you guys will use it later on when you guys learn loops. Alright, so the next operators we're going to go over is the logical operators. These are used to combine Boolean expressions. So let's go over them real quick. So we're going to create a variable, and this is going to hold, it's going to be called isTrue. So you guys know it's going to hold the Boolean, Boolean, and it's going to equal to true. Now we're going to hold another, we're going to have another variable that holds false, and it's going to be called isFalse. It's going to be a Boolean equal to false. So the first logical operator we're going to go over is the AND. And this is specified by 2 ampersands. And we're going to print this out. So AND is only true if both the Boolean expressions are true. So in this case, we're going to use isTrue, and we're going to use the 2 ampersands which specify AND. And we're going to put isFalse so you guys can see what I'm talking about. So right now we have a variable that holds true, and we have a variable that holds false. And if you run that, we will see that it is returning false, because AND is true and is false returns false. Now if we were to make this is true, it will return true just by the rule of AND. Now it doesn't matter what order we put it in. If we were to put is false here, it's still going to return false. If we put both false, it's still going to return false. AND needs both Boolean expressions to be true, and that is just the rule of AND. The next logical operator we're going to use is OR. This is specified by 2 pipes, and we're going to print this out. And or, the rule of or is that only one of them have to be true for it to return true. So we're going to use is true, two pipes to specify or, and we're going to use is false. We're going to run that, and we'll see that it returns true, because this is true. No matter if this is false, at least one of them were true. Now, if we were to put is false for both of them, just by rule of or, there was no true included in this statement, so it returns false. Now, also for or, the order doesn't matter as well. We can put is true on the other side, and as long as true is in that statement, that expression, it will return true. So either or, you know. And the last one we're going to go over is not. This is just an exclamation point, not. And we're going to print that out. And this literally just takes one of them. It doesn't take two like the other logical operators. It takes one of them, and it essentially negates the value. So if we have is true, right, and we prefixed it with the logical not operator, this will make it the opposite of the value that is true is holding. So if we run that, we will see that it will return false, even though is true is true. It negates it essentially. And if we were to put is false here, then it will return true, because it negated is false to return the opposite of the value that it holds. So these are the three logical operators that Kotlin has. You have the and, which both of the Boolean expressions in this statement has to be true for it to return true. We have the or, which is, you know, just as it says, either or has to be true for it to return true. If it doesn't include a true, then it returns false. And then you have the not, which essentially negates the value of the expression provided. So you have a false variable or expression. Then if you use not in front of that expression, then it returns the opposite value. So in this case, this is false. If we negate it or if we put not in front of it, then it will return true. All right, so in Kotlin, we have a thing called string template. This allows us to inject variables or expressions into a string. Let's take a look at an example to see how it is done. So first, let's create a variable. Let's call it slogan. We'll make this of type string, and it's going to equal to just do it. Whoops. So you guys know where this is from, then that's a bonus. If you don't, that's okay. And just like how we would normally do it, let's print this out. And we're going to create a little prompt. What is your favorite slogan? Let's put a colon. And before, if we want to add this variable into it, we'll use a plus and then the name of the variable, which is slogan. And that is concatenating it. But if you guys hover over this, it will say convert concatenation to template. There is an alternative, and that is string templates. This allows us to inject it directly into the quotes, and it will work perfectly fine. So to start off, or to create a string template, you will literally just add a $, and then use the name of the variable. This will let Kotlin know that you're trying to inject a variable into the string. And in this case, we have a variable called slogan, and it's holding the value just do it. So if we run this, we get what is your favorite slogan. Probably should have put a question mark. That's okay. But then just do it. We see that Kotlin injected a variable into our prompt, and it worked perfectly fine. We don't have to add a plus and then the variable. And, you know, it's a very convenient, you know, way of doing things instead of having to do all that extra stuff. We are not just restricted to just variables. We could also inject expressions. And what I mean by expressions is we can use, you know, the methods that come with a string, which is to uppercase or to lowercase. So let's see that in action. And let me just put a expression injection. So let's see. Let's print ln again. And let's put least favorite quote or slogan. And let's copy this. And let's put least favorite slogan. Now, what is my least favorite slogan? I'm just going with "we got the meat" because I really can't think of any other slogan. But I'm not gonna forget the question mark this time, and then we're gonna add this colon, and we're gonna inject an expression. All right. So right now we have the slogan called "we got some meats," but I want it to be uppercase, just to add emphasis. So I'm gonna use a $, and I'm gonna put open and close brackets because we want to let Kotlin know that we're gonna use an expression, not just a regular variable. So I'm gonna put the name of the variable, which is least favorite slogan, and I want to use a method that will uppercase this slogan. So I'm gonna put dot, and then I'm gonna put 2 uppercase, and this will let Kotlin know that the values within this variable, I want it to be uppercase, as the name implies. And if I run that, boom. What is your favorite slogan? Just do it. And least favorite slogan, we got to meet. So I mean, this is pretty convenient. I don't have to do any extra stuff. I can just, as I'm typing, just inject it right in, and it works perfectly fine. And actually, this is not really a question. This is kind of, what is your least favorite slogan? That's perfect. That's proper English. All right, so that's how you guys inject or use string templates to inject variables or expressions into a string. All right, so to write comments in Kotlin, we'll use first the single line comment, which is 2 forward slashes. Everything after the 2 forward slashes is considered a single line comment. So, all right, that if you're using an IDE, you will see that everything after the 4 slashes is grayed out. So this is to let you know that this is a comment. This won't affect the code that you're writing, and it just allows us to put our logic into words that we understand. But everything after that, everything after these 2 forward slashes is considered a comment. But if we were to go on another line, we're back to writing code again. But there is another type of comment, which is multi-line comment, which is / asterisk, and then we would have to close it, which is asterisk and another / Anything within these 2 asterisks is a comment. So we can have the first line, we can have a second line, and more until we're out of this asterisk or these closing asterisks and / Anything after that, we're back to coding. So the single line comment is perfect if you want to keep things brief, or maybe you have a title that you want to put, and then you have the multi-line comment if you want to describe even more. So usually you see these in the beginning of a class. You have them in front of a pretty decent method. So it just allows us to put our words into something that people understand. Maybe it's for your team, maybe it's for yourself. Comments are perfect to add more knowledge or more understanding of what you intend on writing or what you already wrote. All right, let's talk about functions in Kotlin. Functions are modules of code that does a specific task. We use functions in Kotlin or in any programming language to break down our code and to allow for reusable code. So in our case, we kind of already seen a function, which is the main function. This is the entryway into our application. And we already know that if we were to put anything within these brackets, the code will be ran when we run the application. But we can also create other functions. And to create a function in Kotlin, we use the keyword fun, and then we have to choose a name. In my case, I want to make a function that will output a prompt to say hello to a user on start of the application. So I will put hello prompt as the name of the function, then use a parentheses, and then open and close brackets. Now, just like with a variable, we could specify a type for a function. So after these parentheses, we could use a colon and then specify the type that we want to be returned. By default in Kotlin, a unit type is returned. Unit means that no value will be returned from this. So just like in Java, there's void, which means that no value will be returned. So if we have a double or string, any of that, we're not returning that. A unit is the same logic. There is no return type. We're not returning a value. But that does not mean we can't print a value. So by default, it is a unit, but we do not have to put it. We can let Kotlin infer that it's a unit. And we'll just put print ln, and then we can put our prompt, which is hello, comma, welcome to my application. So now that we have hello prompt, we have to use it. So we can go into this main function, which is ran when we run the application, and put hello prompt parentheses. This will let Kotlin know that we want to run this function right away. When we press this run button, we should see after this builds, and that might take a little bit, it says hello, welcome to my application. That's pretty cool. And we can do this as many times as we want. And that's what allows for the reusability of a function. We don't have to keep typing out println. Obviously, this is a very basic case, but we can literally have a whole bunch of code, or not a whole bunch. You should try to keep functions as small as possible, but we can have reusable modules or functions, and we can run them just like this. And if I were to run this, whoops, you guys should see the prompt 4 times. Alright, so in Kotlin, we can pass in values into a function to be used in our logic within the function. So let's see that in action. Let's create a function that will double the value that we pass in. So let's call this double the value for the function name. Let's put a parameter that we can pass into the function. So in this case, we'll just call it number value. And we have to make sure that Kotlin knows the type that the person is going to pass into it, or that the person should pass into it. So we're going to make sure that the person is required to pass in an int. And then we want to return an int after we double it. So we're going to make sure that this function has a return type of int. Open and close the brackets, and we are good to go. The little red squiggly that we see is to let you know that we have to use a return to return the integer type. It says a return expression required in a function with a block body. So we let Kotlin know that we're going to return an int, so we have to do that. So we just use the keyword return, use the inputs that the person is going to pass into this function, and the name of that is going to be number value. And then we're going to times that by 2. So we're going to return the number value that the person passed in to this function, and we're going to multiply it by 2 to get double the value. Let's erase 3 of these. So then the next thing I'm going to do is create a variable called double the val, and I'm going to make this an int, and I'm going to make that equal to double the value. And I'm passing my favorite number, which is 7. And actually, let me just make this more specific. Hold 7 twice. And then if I print ln, I just put hold 7 twice, and I should expect to see 14. So let me explain this again. We have a function that we created. It has a parameter of type int called number value. and the person can pass in a number, which we'll take and we'll multiply by 2 to get double that value. We return that value back after the logic is done. And now this is pretty much a 14. This is holding 14 after everything is done. We can assign that value into a variable, which we have called hold 7 twice, and we can print that out. And that's it. That's what we see right here, which is 14. Amazing stuff right there. With functions, you're not just restricted to just one parameter. We could just make another function, and we're going to call this favorite food prompt. We're going to open this up. We're going to take the name of the user, make this a string type, and we're going to take another parameter, which is going to be favorite food. Whoops. Favorite food. And this is also going to be a string. We're going to make this a unit. We can specify it, or you can just like call it infer that it's going to be a unit, but I'll specify it this time so you guys can see. I'll open up the brackets and I'll just have a simple println. And I am going to make a prompt that says hello. I'm going to use a string template here with name. Then put a comma and your favorite food is, use another string template. Oh, whoops. My favorite food is pizza, but not in this case. Just put favorite food. So it should say hello, your name, and your favorite. Got that. Food is, boom. So in the main function, we could just put favorite food prompt. We can pass in the name, but let me show you a cool thing. You can specify, say for instance, you don't know the order of the parameters. If you know the name of the parameters, you could just use name, put an equal, and pass in the value that you want to use. So in my case, it'll be Giovanni. So that you don't get lost by the parameters, you can specify it exactly. The only problem with this is that if you specify one parameter, if you have multiple parameters, you have to specify all of them. So in this case, I have to specify favorite food as well. So in this case, I use pizza. And boom, you guys can see I have a parameter name, which is name, which is the first one. I have favorite food, which is favorite food right here, the name of this parameter, and I'm specifying it as pizza. We can even change the order. Because we're specifying it, it doesn't even matter what order this is in. No problems. But, you know, if we were to just put pizza first here and then Giovanni here, this will mess this up because it will just see that, oh, you're passing pizza into name and you're passing Giovanni into favorite food. That's not what we want, but we can make it more specific by passing in the actual name and assigning it a value that we actually want. So let's just run this so we can see. So boom, you see hello Giovanni, your favorite food is pizza, and it's not even in the correct order as you would expect. But if we were to erase this and just pass in how it is right now, you will see hello pizza, your favorite food is Giovanni. Kind of trippy, but you know, now you guys know that there is an alternative if you know the exact name of the parameter. This makes much more sense. Also, if you think that the user is, you know, gonna play with your application and not pass in the value that you expect, or not pass in any value, you could put a default. So I could just put guest here, and you could just put what's something that everybody likes. You can put ice cream. Hope you're not lactose. But you could put a default value just by assigning a value to the parameter. And just in case nobody puts in a value, so let me see. So if we just erase all of this and run it, it'll say, hello guest, your favorite food is ice cream. You don't have a choice. This is the default values. So that's pretty cool stuff. You can either let it be free and let the person decide for themselves, or you can place a default value just in case the user forgets or just doesn't put any values for the prompt or for any function that you intend on using it for. So that is functions in Kotlin. Hope you guys enjoyed. Conditional expressions are expressions that produce a result based on the criteria passed. The first conditional expression we're going to go over is the if expression. And just as the name sounds like, if a certain criteria is passed, then we will run a certain amount of code based on what you specify within that block. So instead of talking about it, let's go over an example so you guys can get a better understanding of it. So a good example that I wanted to use, because I want to make something fun, is a coin toss. So you guys know in the beginning of a game, like an NFL game, they do a coin toss to see who gets the ball first, or who chooses to get the ball first. And you choose between heads or tails. So what I wanted to do was make an interactive game where the user can input a choice between head or tails, and based on the choice, if I run a random number between 0 and 1, if their choice matches up with whatever was generated, then you win. If not, then you lose. So how I'm doing that is, first I'm creating a variable called coin toss, which is holding heads or tails in that side of an array. We're going to talk more about arrays, but it's just contiguous memory which holds data, so I can retrieve this value based on the index or the order that it's in. So I can retrieve head by using the number 0, and I can retrieve tails by using the number 1. I print out a prompt which let the user know to choose with either heads or tails. I take in some input, which we're always talking about printing out using println, print, and all that, but you can actually take an input in Kotlin using readline function. So it's literally just readline and then parentheses, and this is going to be storing the value that the user chooses, which is head or tail. And I'm using string, and this question mark is used to let Kotlin know that sometimes the user doesn't make mistakes. So sometimes the user might not make a choice and it might be null, so we gotta be sure that that's okay. And that question mark let Kotlin know that it's okay to store null if the user passes in nothing. And then in this case, we're going to print out the choice that the user makes, and I want to generate a number between 0 and 1. So this is how I do that. This dot lets Kotlin know that we want a range of numbers between 0 and 1. So in this case, it's only 2 numbers, and I want to generate a random number between 0 and 1. So it's either going to be 0 or it's going to be 1. Based on that, I'm either going to retrieve head or tail. So now we're going to use the if expression, which is if, open parentheses, and within this parentheses, I'm going to put the criteria that I want to check for. So in this case, I want to retrieve the value from the coin toss. So I'm going to use coin toss, which is this variable that's holding head or tails. And then I'm going to use the random number that was generated to retrieve either head or tail based on whether the number that was randomly chosen is 0 or 1. So I'm going to put random number. So I use this to retrieve that. And then I use double equal, which we learned, to compare with the user side choice. Then I open up a bracket. So if this is correct, if this is true, we will run whatever is in here. So in this case, I just want to print out you were right. Congrats. That's it, something simple. Oh, I forgot the quotations because I'm printing out text. Congrats. And then the if has another expression that you can use called the else, which if it wasn't met, if this is false, this will run. If, or else, in this case, the else case would be, I want to print out you lost. That's it. So even if the person puts nothing, it's still not going to equal to, the choice, because you can either be heads or tails. If the person put 1, or if the person puts a number or puts something random, the else case will catch that, which is perfect. It's perfect for if the user doesn't put exactly what you want, or if the person just loses. All right, so let's run this. So if we press this play button, and it's gonna take a little bit, we get the prompt, choose head or tail. In this case, I want to choose head. Press enter, and whoop, that was quick. I lost. The choice that I picked was head, and it just let me know that I lost. Let's run it again. Let me choose head again. Boom. Choice is head. You are right. Congratulations. So this is a pretty cool way to see how conditional expressions can be used in your application. If you want something to check a certain criteria, this can be used to execute a certain block of code if that criteria is met. If not, then we can use else to run something else. Alright, so the cool thing about if or else expressions is the fact that we're able to return a value based on the criteria that we pass. So before, we did a little game where we checked if the person was of age to drink in the US. And before, we just printed out some prompts, whether it was true or false. But what if I want to store that value so I can use later on in my application to block out information based on if the person is of age or not? Well, now we can do that with the if or else expression, because we can store that into a variable. So first, let's create a variable called age, and we're going to make that a var because the person's age can change. And we're going to make that an int, and we're going to make that equal to 20 because I want to see if the person is now of age, what will happen. So then we're going to use var and is of drinking age. Boom. And then we're going to put it as a Boolean because it's either going to be true or false. And then we're going to see this expression in action. So let's do if, and then let's put the criteria. If the age is greater than or equal to 21, then we're going to put println first. So we want to print out congrats. Well, not congrats, because it's not really a congrats type of thing. Enjoy your drink. That's all it is. And then we're going to put true as what's going to be returns. Now you're still probably seeing this red and you're thinking, oh man, this guy does not know what he's doing. But in this case, it's pretty much Kotlin letting you know that yes, you have an if, but what happens if the person is not greater than or equal to the age of 21? We're going to use the else for everything else. And we're going to print out, you're not missing out. Just wait. And we are going to return false. Boom. Red swigglies are gone. So if the person is greater than or equal to 21, then we'll print this out and then we'll store true into this variable. If the person is not, then we will print this out and we will store false. Granted, we do not need these prints. I'm just doing that, just so you guys can see. But yeah. Now we can print out whether that is, correct. So, are you of the US drinking age? And then, actually, it's a question. But then I'm just gonna, put on what was actually stored into is of drinking age, and we're gonna print this out. Let's see what happens. That's gonna take some time, and then boom, look, you're not missing out. Just wait, and it's asking you, are you of the US drinking age, and it's saying false. Now if I put 21, which is equal to, it's not greater, but it's equal to 21. Let me run this. Then boom, enjoy your drink. It is true, and we are good to go. So that's pretty useful if you want to, return a value to be stored into a variable. The if or else expression can be very useful. All right, so the next thing we're going to go over is the when statement. We have the when statement and we have the when expression, but we're going to go over the when statement first. Now, this allows us to check multiple criterias, and whatever criteria is passed first, that is what we run with. Now, to show an example of this, we're going to create a hot or cold type of game where I'm going to pre-select a number and we're going to let the user know if they're hot or cold towards, choosing the right value. Now, I already have a prompt that lets the user know to pick a number between 1 and 50. And we're going to take in that value and we're going to store it as a user number choice. Now, to create a when statement, we just use the keyword when, open up parentheses, and we pass in the user number choice. And then we just open up some brackets, and now it's time to start writing some criterias. So the first criteria that I want to put is just a range. So the number that I want to pre-select is 30. So the range that, I want to select first is 1 through 25, and that's going to let the user know that they're cold. So we're going to do in, which lets Kotlin know that we want to first take this user number choice, which is just, the number that the user specified between 1 and 50. And we want to see if it's in this range of numbers that we're about to specify. So 1 through 25 is the range that we're going to use to, let the user know that they're cold. And we're going to take this user number choice to check if it's within this range. And if it is, then we'll print out. And we have to use this arrow to, if we have to use this arrow to let Kotlin know that if it is within this criteria, we want it to run something specific. So in this case, we wanted to print out that, it's code. Or you are code. Got the cap. Now, the second range I want to do, or the second criteria that I want to specify, is 26 through 29. That means the user is very close, so that means they're hot. So I'm going to use this arrow to point to what it needs to run if that person is within that range, and I want to print out you are hot. Now, if they pick exactly 30, which is the pre-selected number, then we just put the exact number, and this will check if the user number choice is equal to 30, and if so, we just want to print out you are correct with a lot of exclamation points. Now we have the other side. Now if it's 31 to 35, or if it's in the range of 31 to 35, and these two dots specify that there's a range. So this is the first number and this is the second number, 31, and everything in between to 35. And then if that number is within that range, then we'll print out you are hot. I've got to put the quote, you are hot. And then the last range check is from 36 to 50. Put the arrow. If it's within 36 to 50, then you print out that you are cold. One last thing is, just like with the if statement, we can also have a fallback if it doesn't meet any of these criterias, and we can use an else, and then we use an arrow to specify what we want to do if it passed none of these criterias. So in this case, we'll just print out doesn't apply. So let me just run this back. Doesn't apply. So we take the user number choice, which is the input of the user, which is a number, or which should be a number between 1 through 50. If the number is within 1 through 25, then we print out you are cold. If the number is between 26 to 29, you are hot. If it's equal to 30, which we don't have to use in because this is not, a number within a range, is exactly the number 30. If it's exactly 30, then you print out you are correct. If it's in 31 35, you print out you're hot. And if it's 36 to 50, you print out your code. And if it's something random that the user put in, like if it's a character or something, we just print out it doesn't apply. So let's run this. Your codes. Okay, since this is not in a loop, it's not gonna like continually run. We're gonna talk about loops later on, but every single time we want to run it, we have to just play it again. So let's try 28. Well, I'm hot. Okay, let's try 33. Oh, I'm hot again. Let's try 49. Your codes. Oh man. But now I know the magic number is 30. You are correct. That's cool. Now, if it's a number that, we don't expect, like it's not in the range that we expect, we have the fallback else, and we can use the number 99 to see this. If we put that, it doesn't apply because it's not within the range that we specified. Obviously, we may have cases where, a user puts in a letter or something, and we're not going over that. This is just a perfect instance of it, and as you guys go on throughout the series, there'll be fallback options for that. But if it's not within the range that we specified, we have the else that will put does not apply. So this is a when statement. This is pretty cool. We can have multiple criterias, and if a criteria is met, then we can do an action based on that. And if it doesn't, we can have a fallback that prints out or does something else. Alright, so just like how there's an if expression, we also have a when expression. And this will return a value if any of the criterias are passed. So in this case, we're going to create a calculator. I already have some setup code. We have 2 prompts that will let the user know to pick a number or integer to be specific. And this is just a fallback just in case no number is picked. This is called the Elvis operator. We're going to talk about it later on. But there's also other things that need to be checked, like if the person actually puts a number, which we didn't do here, but we're just going to act like everything is perfect, and we're just going to put normal numbers. And then we have another prompt that will ask the user to pick an operator, which we went over all of these operators before, which is just addition, subtraction, multiplication, division, and modulus. Now we're going to take this operator and we're going to use a when expression to return the value based on the 2 numbers that the user specified. So to do that, we'll create a variable called answer, and we're going to make this equal to a when expression. So we're going to open up a parentheses, we're going to pass in the operator, open up the body, and then the first criteria I want to specify is the addition criteria. So we're going to put in a plus. We're going to pass in an arrow to let Kotlin know that this is what we're about to do. This is what we want to return after we do it. So we're going to do a num1 plus num2. So if it's a plus, or if the person passes in a plus, then we want to point to this mathematics right here. So num1 plus num2, and it will return the answer of this. We don't even have to put return. It will return this calculation. Then the next one we're going to do is we're going to do minus, and then we're going to point to num1 minus num2. Then we're going to do multiplication, which is asterisk, and then point to num1 times num2. Then we're going to do division, which this can also be dangerous because what if the person uses 0 as the second number? But we're not doing checks for that. We're just showing a very basic implementation. So we're going to do num1 divided by num2, and then we're going to do modulus, which will return the remainder if there is one. And then we're going to do num1 modulus num2. Then we're going to have else, just in case it's none of these. And we're just gonna print out, well actually, yeah, we're just gonna just return 0. That's it. And we should be good to go. Actually, let me just print this out to make sure we actually have the right answer. So your answer is, we're gonna use string template, and oh, that's spell. You're right. Your answer is, and it should be the answer that is storing this. I didn't specify a type because of the fact that I want to let Kotlin infer it, because if we use division, it can be a decimal. So let's run this, and we're just gonna act like a top flight user. We're not gonna add any funny business, but we're just gonna do 5 and another 5, and I want to multiply it because I want 25, and then boom, your answer is 25. Now we're gonna run this again. We're gonna do 5, we're gonna do 1. We want to add this, we want 6. Boom, your answer is 6. Now we want to do 10, and we want to do 7 because I wanted 3, so I want to subtract. So boom, 3 and 1, or actually I lost count. I think we need 2 more, so we're gonna do division. We're gonna do 24 and 6. Let's do division. Boom, 4. And then we have modulus. I want to do 5 and 5. So this should return 0 because there shouldn't be a remainder. Boom. Now let's play the funny user a little bit. Let's do 4. And let's do 2. But for the operator, I just want to act funny. Let me put a little and. Your answer is 0. We don't play that funny business. So that's how you can use when to make a calculator. This is a very basic implementation of it. Obviously, there's some things that will cause this thing to wreak havoc. Like, if I were to divide, 4 by 0, that would destroy this thing. But, obviously, the more you go on, the more you guys will learn more ways to make sure that does not happen. So let's continue on. But this is a one expression. Alright, so now we're ready to dive into loops. So the first loop we're going to go over is the for loop. And that allows us to iterate through a collection of data with an iterator. So that includes ranges, arrays, and collections. We didn't really talk about arrays and collections yet, but we did dabble into ranges a little bit when we went over it in the when statement examples. So we're going to use that in this example. So the for loop allows us to iterate through a collection of data one by one, so that we can see what's inside, or we can manipulate it however way we want to. So to do an example real quick, what you have to do is write out 4, open parentheses, and open brackets, just like most things that we use so far. Now within this parentheses for the for loop, we have to specify the collection that we're about to, or the collection, range, array that we're about to iterate through. So in this case, I want to have a variable called item that is within this range of data. So I'm going to make this 1 through 25. So what this is this is a single instance of an item within this range. All right, so this can be 1, this can be 2. As long as this is iterating, this is going to be an instance within this range, and this is going to make sense once I print it out. So what I'm going to do is I'm going to print, and then I'm going to have a string, and this is going to be called index, and then I'm going to have a little colon, and then we're going to do a string template of item. So this is just going to be a range that I talked about before in the when statement example. These dot dots specify that I want a range of numbers between 1 and 25. So when I run this will print out a whole bunch of prompts, or a whole bunch of text. This has index, colon, and look at this. It takes item. Item is just an instance of each item in this range, or each number in this range. So at first it's 1 because the first instance in this range is 1, and then it continues to iterate. It prints this out, go back to the top, takes the next number in the range, goes here, print it out, and then it goes back and back. I keep going back and forth until you get to 25, and then it ends, because you're iterating throughout each one, and you're passing that value into this item array, and we can use that to print it out, or if you want to do some addition, or if you want to do anything, or later on when you do when we use arrays, you can use that value to retrieve a value in an array, which probably sound like gibberish right now. Or if you have some background knowledge in arrays, you'll know that an array uses an index to retrieve a value. So this is going to be important for that type of stuff. So if you're using collections, arrays, or if you just want to iterate through a range, this is going to be wonderful. And if you have used any other language, this is a very similar, or this pretty much is a for each loop. So to repeat again, we have item, and this is in the range of 1 to 25. This item is just going to take a single instance of a number in this range, and it's going to pass it to be used in this block of code. Now in this case, we have an item, and the first instance is going to be 1. You go back to the top, it's going to be 2, and it's going to keep iterating until it gets to the end of the range, which is 25. Interesting stuff. All right, so the next loop that we have is the while loop. This loop would check if the criteria or the condition is true, and if it is true, the body within the block is ran. Now let's write something out to make for this to make more sense. So we're going to create a variable called counter, and this is going to be an int, and it's going to be equal to, let's make it 5. We're going to make a while loop, which is just while, open parentheses, and then we're going to have the block of code that we're going to put within. Now, when I mean the condition has to be true, the thing that we place inside this parentheses has to be true for this loop to continue going on. So the condition I want to set is I want this while loop to continue as long as this counter is greater than 0. Now if it is less than 0, or if it's equal to 0, then that means that we want this to end. So if we print and then counter, so we can see how this affects it, and then we do counter minus minus, so each time this runs, it will subtract 1 from counter. We run this, we will see, boom, 5, 4, 3, 2, 1, and it just keeps going, from the top to bottom, because it's running in a loop. But once it gets to 0, we got to stop because it's not greater than 0. So that's a while loop. It can be useful. Like when we did the little game before with the calculator, we could place that inside of this while loop, and if the person types in end, we can have a flag that triggers a Boolean that makes it true or false, and we can end that while loop. So there's a lot of things you could do with a while loop. All right, so when you're running the while loop, the condition has to be true for it to run, but you also got to be careful that there is an ending point, because you can have instances where this continue running forever if this is never change, or if it never changed to false. So for this example, I have a very extreme case where I'm legit passing true as the condition to this while loop, but this is just to show you guys what can happen if you don't have an ending point to this while loop. So if I run this, as you guys can see, it's just continue going and going and going, and this is what you call an infinite loop, because it's going to keep going and going and going, because the while loop never ends. It's never going to be false. So when writing loops, you always got to be careful, and in this case I can just press stop, but you always got to be careful because this can continue going and going and going, and if this is a real application, this can crash your code. So because at one point the counter is gonna overflow, so always be careful. Always make sure that the while loop can eventually turn or can eventually end, because you have a thing called infinite loops. Alright, so the next loop we're going to go over is the do while loop. Now, what makes this do while loop different from the while loop is the fact that the body will be executed once, no matter what. So even if the condition is false, it will still run at least once. So let's see this in action. So we're going to have a variable that holds 0. So I'm literally going to call the variable hold 0. And we're going to make this equal to 0. And we're going to have a do while loop. So we're going to have do first, and it's just going to hold our body of code that we want to be executed. And we're just going to have this print out, let's code. And then we're going to have the while that will hold the criteria that checks what makes this run or continue running. So we want to check if hold 0 is, not equal to 0. We know that is equal to 0, so obviously this should be false, but let's see what happens. Boom. So as you can see, it prints it out no matter what. We know that hold 0 is equal to 0, but with the do while loop, this is going to run at least once, no matter if the criteria is false. So if you just want to check something real quick, or if you want to just take a user input to check something out, this can be useful. So the do while loop, if you want your code to run at least once, to check the do while loop is perfect. Alright, so now it's time to go over ranges. We went over a little bit when we used the when statements and the for loop. This helped us create an interval of numbers that we can go through. But let's dive in a little bit deeper and try to customize it just a little bit more. So let's create an if to check if a number is within a range. So we're just going to create a val called y, and we're going to make that equal to, or actually no, let's make it x. It's going to equal to 9, and we're going to check if x is in the range of 1 to 10. If so, then we'll print out, or println, yes, x is within the range. So this takes the value, which is x, which is 9, and checks, and using this keyword in, to check if x is in this range. And we specify a range using 2 dots. In the beginning of the 2 dots, we use the beginning of the interval that we want, which in this case is 1, and we have an ending of the interval, which is 10. So we're doing 1 through 10. So is 9 within 1 through 10? We shall see. Yes, 9 is within, or in this case it says with, but yes, it's within the range. Cool stuff. That's a very basic implementation of it, but that's a way you can create an interval and check if it's within or if it's in the interval. Now another use case for an interval is a for loop. We can iterate through an interval. So in this case, we'll have another variable, or another, maybe we call it a variable because it's going to be holding a value, but we're going to have y, and we're going to use in, and then we're going to use an interval of 1 through 7. And it's not the same as how we have above. In the if case, we're checking if a value is within a range. In this case, in the for loop, we're assigning each value within the interval to y. And as it gets assigned, we can do some logic within the blocks, like if you want to access an array value, which we'll be going over next, or if you want to do some manipulation, some multiplication, anything really, you do that. But then after you're done within this block, it goes back to the top and y grabs another value within the range. So let's print this out so you guys can get an understanding or see how that is working. So once again, I am printing a number, and we're going to use some string template. And we're gonna run this. So once again, I am printing a number, and then boom. As you guys can see, this is y right here. But y is always gonna change because of the fact that it runs this line, it runs what it needs to, but then it goes back to the top because it's a loop, and it grabs the next value within the interval, which is 2, 3, 4, 5, 6, and 7 until it gets to the end, and then the for loop is done. So that's another use case for it. Now, when using a for loop, you're not just restricted to just going in an ascending order. We can go in the descending order too. We can go from 7 to 1 or whatever number you choose to whatever lower interval you choose as well. So let's do that. Let's do 4. Let's choose, we already use y, so let's use z in this case. And if it's within, let's do 7 down to 1, or actually, yeah, just like how I said it, down to. This is another keyword that it's another keyword that let Kotlin know that we want to reverse it, that we want to go from a higher number, which is 7, down to a lower number, which is 1. And we can print that out. And in this case, I'm just going to print out z. And let me comment this out so it doesn't affect how it looks. I'm going to print ln because I want it to be on separate lines. And then boom, it's going from 7 to 1. It's going not in ascending order, but descending order. So we could reverse the order at which, it outputs, or at which it iterates. And lastly, we are not just restricted to just iterating by 1. We could iterate by 2, 3, 4, whatever you specify. And we can do that by using the step keyword. So let's do that real quick. So, wow. X, or actually we already used X, so let's use A. Well, A is in 1 to 10 step by, let's do 2. And then we can print out A. And then we comment this out just like the above. And if we run this, we have an interval of 1 through 10, and we're stepping by 2. So it will go 1, 3, 5, 7, 9. It won't go to 11 because that's not within the interval. So it stops at 9. Cool. We're not just restricted from going in ascending order. We can also go in descending order as well while using step. So let's do that. Let's do B is in 10 down to 1. We're going to step by 3 this time. And then we're going to print B. And let me just comment this out. And when I run this, oh, I always forget the ln. Your disappointment. But yeah, 10, 7, 4, 1. So it just goes by 3. So it starts at 1, it goes to 4, goes to 7, and it goes to 10. So we're not just restricted to going in going in ascending order, and we're not just restricted to just iterating by 1. So there's a lot of things you can do with ranges, and you're not restricted to just doing one certain thing. There's many things you can do. So that is ranges. All right, so let's dive into arrays. An array is a data structure that holds multiple items of the same type or multiple types. The data is stored in a contiguous memory location, and the values are mutable, which means they can be changed. The size is fixed and can be accessed by using the index. The index is the location of the item or the element within the array. I'll place a picture so you guys can get a better understanding on how an array looks like. So let's create our first array. So I want to create an array with names within it. So I'm going to call it names, and I'm going to make that equal to an array. So to create an array in Kotlin, you use the array of with parentheses. This is to let Kotlin know that we're about to create an array and we're about to add elements within the parentheses to start defining the elements of an array. So let's start writing down some names. So the first one I want to use is Joey. Second one I want to use is Valentina. The second one, or third one I want to create is Maria. And let me fix the A. And the fourth one I'm going to put is George. Now I want everybody to also have an age. So we're going to put another array called ages. We're going to make that equal to an array. Now an array could specify a specific type just like a variable. In this case, above, we let Kotlin infer the types. So in this case, if there's only strings within this array, we let Kotlin infer that there's only going to be, or we let Kotlin infer that it's going to only be a string. But you could also define other types. You could put a 1 in here. You could put a true in here. Kotlin will just infer that this is an array of string, integer, and Boolean. So it is possible. But if we want to make it specific, and then we remove this, we just add in some anchor tags and we place the data type of what we want to specify. So in this case, I'm using ages, so I want to use int. Now let's close that anchor tag, open up parentheses, and let's start defining some ages. So for Joey, he's going to be 22. For Valentina, she's going to be 36. For Maria, she's going to be 20 or 28. And for George, not so curious, but he's going to be, let's say 45. All right. Now, you can retrieve a value from an array by using an index. So with arrays, we start at 0 up to the length -1. So in this case, we have an array of size 4. As a plane go over my house. But we have an array of size 4. It's Joey, Valentina, Marie, and George. But since the array starts at 0, it's going to be 0, 1, 2, and 3. So to retrieve George, we will have to use the index of 3. So let me print this out so it can make more sense. We'll print out a name and we'll print out an age. So let's put println. And then let's put name and use string templates. Since it's going to be retrieving a value from array, we're going to have to use the string template for expressions, and we're going to place square brackets. So to retrieve a value, you have to specify the name that you're holding the array, put square brackets, and then place the index. So since we want to retrieve the last value of names, or we want to retrieve George, we'll use the index of 3. Because like I said, it is starting at 0 to retrieve the initial value in the array, and then it increments by 1. So that means the last value of the array for names will be 3, and that would be George. And I want to retrieve the age of George, and that is 45. So I'll print out age, and we'll also use a string template for expressions and use age. Ages is plural, but we want to just retrieve 1, so we'll open up a square brackets, we'll place the index of 3 to retrieve the last value, and then let's run that. And you guys will see that it says name is George and age is 45. Now, a sure way to make sure you retrieve the last value of this array of ages, or any array, is that you could take ages, or you could take the array name, then put dot size, which will retrieve the size of the array, and put -1. Because like I said, since it starts at 0 and it ends at the size -1, this will guarantee, that you're retrieving the right last element in the array. So let me just do this for names as well. Put dot size, and then put -1 or -1. And if I run this again, we are good to go. But you also got to be careful with arrays because of the fact we could have an exception. Now, what if we try to retrieve a value that is beyond the scope of this array? So in this case, what if we try to take names.size, which in this case will return 4, but we don't have an item within this array that has an index of 4. So if we try to run this, we will receive this array index out of bounds exception. And you don't want this. This can be very dangerous because this is a runtime exception. You won't get this during compilation. It's only when you're trying to retrieve something. So say for instance your application is running and you're thinking it's perfectly fine, but once that one thing triggers, it will break the application. You don't want that. So you got to make sure that you pay attention to this type of stuff because it can break your application. Now we can also change a value. Like I said, arrays are mutable in the sense that we can change the values within the array. We can't add a size or we can't add another item to the array because of the fact that once you create an array, it stays the same size, but you can change the values within the array. So say for instance, we want to change the name George to, Joshua. We can take names, we can open up a brackets, we can grab the last item or last element using the names dot size -1. We can make that equal to Joshua, and then if we run this should be perfect. Joshua and his age is equal to 45. Now you're probably asking yourself, or if you guys don't understand that yet, but it says Val's names. Does that mean that you can't change it? Not with arrays. That just means when it says val, it just means that we can't change what's already being held after we assign it. So in this case, we already assigned names with the array of. So as long as we're not changing it to, a string individually or a number, it's fine. But as long as we're changing just the array or the values within the array that's already being assigned to names, then we're good to go. And you guys see that it was mutable, so we were able to change George to Joshua. So perfect. So you guys get an understanding. If you want to specify a specific type to array, you can specify it with a anchor tag. If you want to grab the last item within a array, you can use the size -1. You guys got to be careful with array out of bounds index when your application is running because it's a runtime error. So you could just be running your application perfectly fine, and then once a user tries to access something that they're not supposed to access, it could break. So you got to be careful for that. All right, so we're not just restricted to just one individual arrays. We can have arrays within arrays. We can have multi-dimensional arrays. So let's create that. Let's have one. It's called numbers, because we're just gonna put an array of numbers. And we're gonna call this array of. Open that up, and then we're gonna have another array of. That's gonna make another row of arrays. Now we're gonna make. Let's make 2. Let's make a square. So then we need to just start defining some numbers within here. We'll just call this 1 and 2. And then we'll just call this 3 and 4. So as you guys can see, it's a square. It's 1, 2, 3, and 4. Now, how do we retrieve 3? So it's the same concept as before. To retrieve the first value or the first element, it will be 0. But in this case, it's multi-dimensional. So the first row will be 0. This second row will be 1. But how do we retrieve the values within the columns? Now, in this case, we have the first row and the second row, but the columns is the same. In this case, it's the same logic. So if we want to retrieve 3, we're in the second row, right? Which is 1 because array start at 0. So it'll be 1. And if we want to retrieve the first value, we'll just have to use 1 and 0, because to get the first element within this second row, it'll be 0. You're probably thinking to yourself, man, this really doesn't make sense. So let's print this out so you guys can get a better understanding. So if we take numbers, and we open up the first brackets, and we want to retrieve a value in the second row, but since array starts at 0, we got to subtract 1. So in this case, if we try to get something from the second row, it'll be 1. And if we want to retrieve the first value in the second row, we have to use 0. Now, if we run this, we should expect to see 3. Boom. Now, if we want to retrieve a value in the first row, but we want to get the second element in the first row, which is 2, we just got to change this to 0 because this is the first row, and we want to retrieve the second value. We just got to make this second one a 1. And if we run this, we shall see 2. Now, you can use for loops to easily go through these one by one, but as you guys can see, there's a lot of things that you could do with arrays. You just got to be careful when you use them. All right, so let's talk about collections. A collection is a group of a number of items, although it could be empty. The first collection we're going to go over is a list. A list is a collection with the ability to access elements by using an index. So let's write a list that will hold some characters. So we're going to use val, make character list as the variable that's going to hold this list, and we're going to make that equal to list of. Just like how we used array of, we have list of, and we can just open up the parentheses and we can start defining the elements that we want to put inside of this list. So we can open up some single quotes and start placing some characters within this list, and I forgot to put a comma right there. All right, so boom. So now if we want to access an item within this list, we just have to use character. Actually, let me just print this out so you guys can see. Print ln character list dot get. So we can either do dot get, or as you guys saw, we can use the square brackets just like an array, but I'm gonna use dot get because that comes with the list. And we can specify the index just like an array. It starts at 0 and then it increments by 1. So if you want to grab something in the middle, in this case there's only 3, so we'll just use 1. And so this 1 signifies that we want to grab y, and we can press run. And voila, y pops up. And just to show you guys that just like an array, square brackets work. Voila, y again. And also we can get the size of this list. So we just use character list dot size. And let's run that. And in this case it's 3. So we should see 3. Now, if you do not know if a list contains a certain element that you're looking for, you can do a check. So this list comes with a dot contain method that will check if your list has the element that you're looking for. So we can put character list dot contain, and in this case we want to see if this list contains the character A. And if we run this, you should see false, because that is not true. It does not contain A. But if we were to put X and we see X is the first element and we run that, we should see true. We can also check for the specific index of a character. So let's just copy this and pasta that, and let's use index of to check what is the index of this character Z. And if we run that, we shall see that the character is 2. So there's a lot of useful things that a list comes with. Now, the one thing we cannot do is we cannot add. We can't add anything to a list. We can't add another character if we want to. So in this case, a list is not mutable. You cannot write to this list. So we have another instance of a list called mutable list, and we'll make some space, call this mutable character list, and we'll make this equal to. Now, before we had list of, but if we want a mutable list, we'll use mutable list of. And in this case, since we know we're going to type char, we can specify it just like an array. We use these anchor tags, and we place the data type that we want to place within this mutable list. And now we can start putting in some characters. So in this case, I'm gonna use A, B, and C. Now, before, character list didn't give us the option to add. We can reverse the list. There's a lot of things we could do with a list, but in this case, we couldn't take a value within it and change it. But with the mutable list, if my mouse can start working, with the mutable list, we can add. And in this case, I just want to add something to the end, so I'm just gonna put D and actually I forgot to put the single quotes. Rookie mistake. Now if I print out this mutable character list and I run it, I shall see A, B, C, and D. Cool stuff. Before, I couldn't do that with just a regular list. We only have read-only access, but with a mutable list, we are able to write to this list. I'm also able to add a whole list if I wanted to. So let's do that. So let's take this mutable character list and use the add all to add a collection of data to it. So we're going to add another list, and we're going to just use a regular list of, and what's F, and then we're going to add G as well. Ooh, forgot to add it to its own character. So we're going to add a separate list of E, F, and G. And let's copy this printout and let's print it out again so you guys can see that this is possible. We can add single characters, or we can add a whole collection of characters if we want to. So now it's A, B, C, D, E, F, and G. We got the alphabets going on. And we could also, let's do this right before so you guys can see, we can remove a character. So let's remove F, and let's run this. Boom. A, B, C, D, E, and then F is gone, but then we'll just go to G. Now, if you know the exact index of the thing you're trying to remove, you can use remove at. So I know I want to remove the last item within this list. So I'm just going to use character or mutable character list. Dot size -1, just to make sure that I'm actually retrieving the actual last element within the list. Now if I run this, we're back to A, B, C, D, and E. So if you know for sure that you want to be able to read and also make changes to the list, which is right, you use a mutable list. But if you know you just want read-only access and you just want to be able to retrieve values from the list, you use a regular list. So that is the first collection in the group of collections that we have in Kotlin. So the next collection we're going to talk about is a set. A set is a generic unordered collection of elements, and it does not support duplicate elements. So let's start off by creating a set that holds the days of the week. So let's make this a file. Let's call this, let's actually just call this days of the week. And we're gonna make this equal to sets of. This is what you use to create a set. Just like list of to create a list, just like array of to create an array, use set of to create a set. And you open up the parentheses and we can start writing in the days of the week. So we'll put Monday, Tuesday, and let's write in Wednesday. Now we're going to create another set, and this is going to be for the weekend. So we'll create one called weekend, make that equal to a set of, but I want to specify the specific type in this case. So I want this to be a string because we know we're going to be holding in strings. So this one doesn't specify the type, but we let Kotlin infer that this set is going to be, a string because we have strings within this set, and we're going to make Kotlin, or we're going to specify a string to let Kotlin know that it's going to be holding just strings. So let's make this, I like to consider Friday as the weekend and Saturday and Sunday, and we are good to go. Now it preserves the iteration order of what we place into this set. So if we print out what we have right now, days of the week, and let's print out, oops, missed the whole entryway. All right, let's call this weekend and let's run this. Boom. So same order: Monday, Tuesday, Wednesday, Friday, Saturday, and Sunday. All right, cool. Now the cool thing about a set is no matter what the order is, let me copy this. We're gonna make this the same thing, but we're just gonna call this days of the week 2, and we're gonna check, does this equal this if I even change, whoops, if I change the order, is this the same thing? So let me just do that, put Monday in the middle. Actually, I need that. So if I make days of the week equal to days of the week 2, is this the same thing? Let's run that. It's true. Even if the order is, out of order, a set is an unordered collection, so they still contain the same values within, so they should be the same regardless. All right, so to create immutable sets in Kotlin, we'll use the mutable set of function. So we'll make an example that uses the months within the year to see this in action. So let's make this equal to the mutable set of, and open up the parentheses, and we're going to place March. Whoops, got to get out of double quotes. April, and then May. Now we can take this variable, which is months, and we can use the dot add if we want to. We can start adding in stuff within this set. So we're gonna use June. We're gonna add June, and we're going to add July. But let's see, what if we try to add July twice? What if we made a mistake? In this case, it's not a mistake, but let's just hypothetically think that this is a mistake and try to add July twice, and we try to print this out. what does a set do with this? We talked about this a little bit in the beginning, but does sets allow this? No, it does not. It just completely ignores the duplicate elements. It only sees this one, but once the set sees, oh, we're trying to add another element that we already have within this collection, that's not good. So we'll just ignore that. So that's what a set does. It doesn't allow for duplicates. And just like with the list, we can also use months.remove, and we can place the string, which is July. And if we run this, it removes July. So it only sees that single instance of July, even though it was added twice. This one was never, the second one was never added, and we just removed the first instance of it. And just like the example above, we could specify a type. So in this case, I'm gonna put holiday months. Now obviously I'm not gonna put all the holiday months because I don't know all of them. But I'm just gonna put, November and December, because that's usually a big holiday season type thing. So I'm gonna specify this as a string, and I'm gonna put November and December. I think I spelled that right. Probably did, probably didn't. And we can add to this, so another holiday. What's another holiday month? I guess there's 4th of July for Americans, so we'll just put July. And then let's print this out. And if you run this, it works just as expected. November, December, July. And then we could even do remove at, just like we did before with the list. If we know the specific index, we can just remove the last element. In this case, I don't know the last element, so I'm just gonna put holiday months, and I'm just gonna take the size, and then I'm just gonna subtract 1, just so I'm sure that I'm taking the last element. And if I run that again, it should just say that, oh, it's saying that I removed July. And so if I run this again with just holiday months, it should just be November and December. Boom. So yeah, if you want an unordered collection, you don't want duplicates, sets are perfect. No matter if you are trying to, if you use 2 sets, no matter what order they're in, if you make them equal to each other, if they have the same elements within it, they're still the same set, because a set is unordered. Alright, so the next and last collection we're going to go over is the map. The map is essentially a dictionary. It is a set of key value pairs. Each item in a map can be accessed by a unique key. The map holds only one value for each key. So now, in this case, we're legit just going to make a map. We're going to have a map that holds countries. So let's create a file. We're going to call this map. Let's make it more specific. So map of countries. And we're going to make this equal to map of. And let's remove that for now. So just like before with sets, a list, arrays, if we want to create a map, we use map of. You see the correlation. To make a list, we use list of. To make an array, we use array of. And to create a set, we use set of. So to create a map, we use map of. And within the parentheses, we can start defining the key value pair relationship. So before with set and list, we didn't have to create a key, but the special thing about a map is that it has a key. So in this case, I want to create a key for each country. So in this case, I'm just going to use characters. So for the US, I'm going to make it have a key of X. And to assign it to a value, you use 2. And then we create the value, which in this case, I want to create US. So the key value pair relationship. The key is X, and that is the key to the value, which is US. Now the next key value pair I'm going to create is for Canada. So we're going to make a key called Y, and that is to assign it to a value of Canada. And just a last key value pair that I want to use is Z, and that is going to be assigned to Germany. So it doesn't necessarily have to be a string, a char. It can be a number if you wanted to, or it can be just a character. And I probably should just use characters for this, because if I'm only gonna make it X, Y, and Z, then I should probably just use characters. But yeah, you're just not conformed to just using one type for the key and the value. So now if I print this out, let's print out the map in general first, map of countries, and then we're going to print out us retrieving. In this case, let's retrieve Germany. So let's use map, and just like an array, we just use the the square brackets to place in the key. So in this case, we want to retrieve Z, map of countries. And then boom. So if we run this, we should see X, Y, and Z, and the values assigned to it. So it's going to say X is equal to US, Y is equal to Canada, and Z is equal to Germany. And if we just try to retrieve Z, we'll just see Germany. And you're not just restricted to that as well. The map does have a lot of predefined methods that come with it. So we can use get, and we can use the char. So let's create Y, or let's retrieve Y, and in this case it should just grab Canada. So cool stuff. Alright, so just like with the list and the sets, we do have a mutable version for the map that will allow us to write to the map. So let's just create a mutable map of countries, and let's call this legit mutable map of countries. And we're going to make this equal to mutable map of, and in this case I know I want to use char for the key type, and I know I want to use string for the value type, and yeah, it's lowercase h. So before we just use one data type to specify the element type, but in this case we have the key and we have the value, we have to specify that. Or we could just call it infer it, but in this case I want to specify it myself, so I just put char and string for the key and the value. Alright, so now we're just gonna copy this from above, because whoops, my finger didn't slide exactly how I wanted it to. Let's copy that, let's paste that in, make our life easy, and let's start writing some data into this. So let's just print out the regular version so you guys can see the original, and then let's start adding in. So I want to start adding some more countries in, so let's just use mutable map of countries. Let's open up some square brackets, and we can specify the key here. So let's specify let's make this A for the key, and we're gonna make this equal to Mex for Mexico, and mutable map of countries, we're going to specify B, and we're going to make this equal to, let's see, what's a nice low key country. Let's call this Nigeria. And then a mutable map of countries, let's make this C, and then we're going to make this equal to Brazil. So 3 should be good. They have a key of A, B, and C. And if we print this out, we will see that we have a difference. So let's run this. Boom. So we have X, Y, and Z for US, Canada, and Germany. And then we have A, B, and C for Mexico, Nigeria, and Brazil. Looks good. All right, so now it's time to start to, remove things. So just so you guys can see how to remove things. Mutable map of countries. Let's just use remove. And in this case, we have to specify the key. So the last thing we added was Brazil, and it has a key of C. And let's also use replace, just so we can see that in action. So we'll take Nigeria and we'll replace it with Dominican Republic. So we'll use DR. And then we'll print this out. Mutable map of countries. Oop, I always make this mistake for some reason. Mutable map of countries. And we'll run this. Let's separate this because this is bothering my eyes. It's still not doing it for me. But let's run this. And then we shall see that Nigeria is not there anymore. It's replaced with DR. Brazil was removed from, this mutable map. And, this is the final result that we get by me manipulating this mutable map of countries. So cool stuff. So now you guys know how to specify, specific data types for a map. You can make the map mutable if you want to, or you just use a regular map if you just want to retrieve from the map that you created originally. So yeah, that is the map out of the collections. Alright, so the cool thing about Kotlin is that by default, Kotlin variables are non-null references, which mean that you cannot assign it to null. So let's say we have, a val called name, and it's a string, and we try to make that equal to null. Yeah, Kotlin doesn't like that. It doesn't like that at all. It can't be assigned to a non-null type. And if you guys use Java, this was a big problem because sometimes, you would get something that holds a null and then eventually get a null pointer exception. So Kotlin's big thing is all about null safety. And this is why by default, they make their variables non-null references. So if you wanted to make anything null or any variable null, you have to let Kotlin know, okay, I really do want to make this variable null. So to do that, all you gotta do is add a question mark. Boom. The squiggly line of death disappears. And this question mark just lets Kotlin know, okay, name can hold null. As long as you know that you're sure. I mean, you told me by this question mark that you kind of know. But yeah, for sure, like this lets Kotlin know that it's okay. You can hold a null in this variable. So yeah, no safety. Now, if we want to check if a variable is null before we use it, we could do that, and that's just a regular if statement would do. We could just use name is not equal to null, then we just print out the name. Whoops. A name, and this, I am bugging out right now. Okay, then my name is, and then if it is not correct, then we can just print out check that again. If we run this, it's gonna ask us to check that again because for sure name is equal to null. So we just avoided so many problems. But if we just put, Geo, my name is Geo, and we're good to go. So that's a way that you could check if it's null or not. Alright, so in Kotlin we have other ways for checking if a value is null or not, and there are fallbacks to that as well. So one way is using the safe call operator, and usually this is used with things that has a chaining effect. So strings are an object and they have predefined functions called methods that come with it. So we can use a safe call operator to check if the string is null or not. And if it is null, using the safe call operator, it returns null. So let's just use that in action so it makes more sense. So we'll just use println. We already have a string called name, and that's outside of it, called name, and we'll use a question mark and then a dot. And these are the predefined functions, or they're called methods, that come with a string. So we're just going to use length. And if we run this, right, we should just expect 3. Oh, I forgot to, let me just comment all of this out. If we run it again, we should expect 3, all right? Now, if we were to just put no, and we run this, it just returns no. And you're probably like, okay, that's expected. I mean, this is null, right? But if we were to remove this safe call operator, see, only safe calls can be called on this because of the fact that it's null, and we already made this notable. Kotlin already warned us beforehand, like this is null. You might want to use a safe null operator, because if we use a dot length on a null property, it would cause a lot of problems. So we can use the safe call operator to just return null if this is null. Cool stuff. The next null safety operator that we can use is the Elvis operator. The Elvis operator is a fallback that will check if a value is null. If a value is not null, we keep the value. Else, we place a fallback value into it. So in this case, we have name, right? And right now we have the value of null within it. So we can use a Elvis operator, which is a question mark and a colon. And with this, we can define a fallback value just in case this value is null. So if it is null, then it will equal the value of the fallback value. So in this case, I want to just use guest, because if I don't know the name of the person, I just want to call you a guest, because you're a guest. So if we run this, we should expect to see guest. Now, if I'm Geo, right, and I run this, you know my name. And you shouldn't put guest. It should be Geo because you know my name. It's not null. And that is the case. So the Elvis operator is very useful if you know that it's going to be null, but you also have a fallback value that you want to put just in case. It's usually better to use this than the safe call operator, in my opinion, because it's, to me, I feel like it's better to have a fallback value instead of just placing null everywhere, because the safe call operator just returns null. So yeah, that is the Elvis operator. You just use a question mark and a colon and a fallback value and attach that to a variable that may or may not be null. Alright, so the next operator we have is the not null operator. This is an operator that is 2 bangs. It converts the value of a variable or a value to a non-null type, but if it is null, it would just throw an exception. So I really don't see much of a use case for this, but maybe if you want an exception if you want to catch an exception, just in case if it's null. But let's see this in action. So let's have a val of y, and this is going to be a string that accepts null. So we're going to make this equal to null, and we're going to have another val that holds, that is x. Oop, forgot to put on another line. Typing skills is trash. We're going to have another val that is x, and it's going to be equal to y, bang bang, bang bang. So if we run this, right, there should be an exception, and there it is, the Kotlin null pointer exception. So it sees that y is null, so if we put the bang bang, it just throws the exception. Nice stuff. If we were to place, let's use a string called value, and we were to use a bang bang on it, it just makes this y into a non-null type. So let's just make this a string. No errors. Now if we run this, or actually no, I didn't print it, but no errors, right? But if I didn't have this bang bang on it, it will be a problem because of the fact that it's a mismatch. One is just a regular string, which is a null reference, and the other is a string that accepts null. But if I use the bang bang or the 2 exclamation points, it reverses the type of y. It makes it a non-null reference. Only problem is that if this is null, then it will throw an exception. If I run this again, it will throw an exception. So you gotta use this wisely. All right, so in Kotlin we have type checks and automatic cast. So the first type check we're going to go over is the is and not is. In Java we had a thing called instance of, or we have a thing called instance of, which checks the type if the value is of a certain type. So it's the same in Kotlin. Is to check if an object or a value is of a certain type. So to do a quick example, we can first, let's create a variable, and we're going to call this thing name because I like names. We're going to call this name Joey. We can use this name and we can check if it is of type string, and if so, Readline, nice name, and then we'll just put name. So if the value is a string, then we're good to go. Obviously, even beforehand, if we try to use another value, it's just gonna straight up tell you that it's incompatible. It's a string and an int. So you could use this with objects to check if an object is a string, but we're not going over objects just yet. I'm going to go over objects in the future, but is used to check if a type or a variable or a value is of a certain type. So pretty convenient. We also have a negated version of that, so it's legit just adding a not in front of this, and if name is not of type string, then we'll do something. If not, then we can have an else case, and we'll just print out it is a string. So boom, so we can check if it is a string and if it is not a string. In this case it is a string, so we'll just catch that in the else. So different ways to check if a value or a variable is of a certain type, just like instance of in Java.